Wow, and turn my volume up. Man. Okay. So I have a few of you have received grades on the midterm and comments on the midterm. I'm making my way through them. Like I said, my goal is to get through them by the end of today. But for now, let's do some math. So yesterday we were talking about solving linear inequalities, and today we're kind of moving on to solve nonlinear inequalities. And this is a topic that I will say I am completely sure I never learned how to do this in high school. And I'm completely sure that even as an undergrad in college, I kind of faked my way through this thing, but it's actually super useful in calculus and shows up more often than you might think. So I'm going to talk through some ways to sort of collect our thoughts when we're talking about this. But let's start off with just kind of a warm-up problem. Hopefully it'll be pretty quick. I'll give you maybe 30 seconds, but I just want you to factor, we'll keep it simple. X squared minus 2x minus 8. So you 30 seconds to get warmed up, get that factored for us. I'm guessing we have this factored. So this is going to become x minus, do you guys get x minus 4x plus 2? Think that sounds right? Okay, so the reason that I was having us factor this is because what I actually want to talk about is I want to solve this inequality. So we're actually going to solve this is less than or equal to 0. Oh, I got a hand already. Yes, did I make a mistake?
I think it's +4 and then -2, I think.
So let's check it out. So the way that we can check our work is to multiply this back out. And if we do that, so if I take my x and I distribute it in, then I'm going to have x squared and plus 2x. And I'll have minus 4x and minus 8. So when I combine these in the middle, I'm going to get the negative 2x, which is what we were hoping for. So I think we're good.
Can it be +4 -2?
So if it's +4 -2, then what would happen when we multiply that out is the signs on these would be switched, right? So if this were +4 and then -2, when we distribute it, we'd end up with a positive 4x and a negative 2x. So when you combine these together, you'd end up with a positive 2x. And that's not going to work because it doesn't match what we started with. So the signs are definitely important. Like where we put the positive and the negative matters. Yeah. Cool. And sometimes, actually most of the time, I would say if something has gone wrong, I always recommend checking to make sure that you wrote the equation correctly, because most of the time what happens is it's actually the writing of the problem where something went wrong. So all good. We'll move forward here. Okay. If this said equal to 0, then we've already talked about if I have two things and they're multiplied together and they give me 0, then one of those two things had to be equal to 0. Well, life's a little more complicated when we're talking about inequalities. So what this says right now is I have two factors. And when I multiply them together, I get a number that's less than or equal to 0. Well, when I read this as less than or equal to 0, that means I have two things multiplied together and the answer is negative. So if I want to end up with a negative answer, what kind of things could these both be? That's like a really terrible question. I don't even know how you're supposed to answer that question. Let me try that again. If I'm trying to multiply two things and get a negative result, do the two things need to be positive, negative, or mixed?
Mixed.
Totally. Because the only way I'm going to end up with a negative number is if one of these is positive and the other one's negative. Now, here is the dumb way that I was like, I don't know how you all were taught to do this. I was taught to do this in a really dumb way. Because this could be positive and this could be negative. And then you'd like work out what numbers make that true. And then go back through and figure out what numbers would make it true for this to be negative and this to be positive. And then you'd like go work all of that stuff out. Then I got to UC Davis and Grant Acosta, who some of you may have met before, I don't know, he's one of my colleagues. He's awesome. Grant was like, you know, we really just have to figure out where each of these pieces are 0. And when you put those on the number line, it breaks all of the possibilities up into just 3 cases. And if we test those 3 cases, we'll know whether this entire inequality is true or not. Well, it turns out that this thing, super useful in calculus, totally necessary to do this efficiently. Oh, thank you. We never switched this back to the correct factors. Thanks for that. Let's make sure I get this back to the correct factors, x minus 4, x plus 2, because that's going to change my number line to be a -2 and a positive 4. Okay, it's all good. So now that I've got the numbers on the number line that make these pieces equal to 0, we're going to do a test case in each of these regions and just figure out whether the whole thing works out to be positive or negative. So I need a number that's less than -2. Any volunteers for a number less than -2?
-4.
And how about a number that's between -2 and 4? I got a 1. And a number that's bigger than 4.
6.
Okay. If your name has an A in it, you're going to plug in -4 to this equation and see if it's true. If your name doesn't have an A in it, you're going to plug in 1 to the equation and see if it's true. And I'm going to do x equals 6.
Does it matter if we plug it into the original one or the factored one?
No, whichever one is easier for you to do the arithmetic on. Doesn't matter. Now I didn't even check. I'm like looking and all of a sudden there's a lot of A's. Do we have some folks without A's in their name? We'll find out. Okay. Any volunteers from the x minus 4 group? Was your final answer when you plugged it in positive or negative?
Positive.
Okay, positive. And how about I just don't know what that says. Pretend it says positive. For the folks without an A in their name, Any volunteers from the x equals 1 group? Did you come up with a negative number or a positive number?
I got a
Negative.
negative.
Cool. So that means because what we wanted was the result to be less than or equal to 0, we were trying to find the part where our answer worked out to be negative. So this is the part that we want. I don't want the part over here where it was positive, and I don't want the part over here where it was positive. Now, the or equal to would tell me that I need to fill in circles. And then if I wrote this in interval notation, because of the or equal to, I would be using brackets. And this would look like bracket -2, comma 4. And then just because I'm curious, quick poll I'm throwing out there. Have you seen this? I'm going to call it number line method. Some people call it a number chart method before. I'm always curious what's going on out there in K-12 education these days. Okay, it's split. We're like at a 60-40 split here. We're at a 60-40 split. So awesome if you've seen this before. If you haven't seen it before, you are also in good company. Now, a few questions came up in the chat. One is, can we walk this through for -4? And for sure, we will do that. And then the other question, oh, yeah. So in case you missed it, I wrote the wrong numbers down here when we started. So cool. Sorry. These are the numbers we're working with for this problem. We'll do another 12 problems and it'll all be good. Yeah, totally. Looking at homework and going, what the heck are you supposed to do? That's the story of me raising my child. Okay, so let's plug in the -4 and show how this works out to be positive also. So if I plug in x equals -4, and it doesn't matter which one you plug it into, I always think it's a little easier on the factored version, but it doesn't really matter. And so here, if we plug in -4, we'd have -4 minus 4 times -4 plus 2. -4 minus 4 gives me a -8, and -4 plus 2 is -2. And when we multiply those together, we get a positive 16. So that's how we ended up with a positive over here. And if this feels a little bit awkward, it'll get better as we do more examples. So I think I want to like just move on, do another example, practice figuring out where it's 0 so that those are the numbers we put on the number line. Oh, let me just indicate this would be my final answer. Or if you wanted to write that in inequality notation, we would say that x is between -2 and 4. So this would be the answer if we were looking for inequality notation. Good times. Yeah, I'm pretty sure that like when I was taking calculus in college, I'm sure my teacher just thought everyone knew how to do this, and it was like never taught, but then we were just supposed to use it. So I don't know. Let's get another example here. I'm looking at 6x squared minus x is greater than or equal to 2. Now I want to pause for a second Just like when if this were an equal sign, it's important to have a 0 on one side or the other before we move forward. The reason being, if I were to take this left-hand side and just for fun, factor out an x, and then have a 6x minus 1 is greater than or equal to 2. Well, there are a whole lot of numbers that I can multiply together and get something bigger than 2. So this isn't wrong. It's an equivalent form to this. It's just not a useful form for us. The reason that 0 is a useful form is that we really only have a couple options if there's a 0 there. If I have a 0 there, by subtracting 2 from both sides, now I'm looking at this and saying, well, I need it to be greater than or equal to 0. So I either need 2 things that are positive multiplied together or 2 things that are negative multiplied together. Let's have some fun with factoring this. So just because we haven't done it in a while, we can go for the X method, and I'll try to get it right the first time. So I'm going to put -1 down here. And up here, I'm going to have 6 times -2. So I've got -12. So I need 2 things that multiply to be -12, but add to be -1. And I'm thinking those 2 things are going to have to be a -4 and a +3. And yes, it matters which one is which. I need my 4 to be negative so that when I add them together, I end up with a -1. For those of you, and I've noticed that on some of the homework and on the quizzes and midterm, some of you are really liking the factoring by grouping. So if you're a factor by grouping person, I'm going to take that -4 and that 3 and split up that -1 so that this looks like 6x squared minus 4x plus 3x minus 2. And then I'm looking for, if I group these together, is there anything we can factor out? And if I group these 2, I can factor a 2. And then I'd have a 2x, sorry. And then I'd have 3x minus 2. And over here, there isn't really something to factor out, but I can see that I have that same 3x minus 2 term. So I'm going to just, for my personal satisfaction, write a 1. And then I can take that 3x minus 2, and since it's common to both groups, factor it out and be left with the 2x plus 1. That is not the only way to get this factored. However you want to get it factored is totally fine. I just realized I've been writing most of them the other way, so I'm trying to change it up a little. You can factor however you want. Now that we are here, oh, I thought I saw coming. No, we're good. Okay, so now that we are here and we've got this factored, we need to figure out what's going on our number line. And anything that makes these two, anything that makes either of these equal to 0, that's what's going on the number line. Oh, and there's a question. You can use the X method to get the factor by grouping. I think this is a good method to get to the factor by grouping. Like for me, any method for factoring is really about keeping track of what you've tried in, or keeping track of like what numbers are floating around in your head. So for me, writing it out like this helps me to see how to split the middle term so that I can factor by grouping. It's just a tool. So there's another question in the chat around something we were talking about yesterday, where if we multiply or divide by a negative number, that we would end up flipping the sign of our inequality. Good news. We didn't multiply or divide to get to this point. All we did is subtract 2 from both sides. And since we were using addition or subtraction, that whole flipping the sign thing doesn't come into play. The truth is, I'm personally almost never going to worry about flipping the sign because I'm just going to move everything to whichever side of the equation is going to make stuff positive for me. Faith, Elizabeth, you got a question?
Yes. So when I did the X method and then I divided -4 and 3 by 6, at that point, does that tell me I need to flip the sign?
Got it. So, okay, now I see where the question's coming from. This is just to get the thing factored. This doesn't even know we have an or equal to. Right? Like when you're factoring, we're just messing around with this side of the equation. When we talk about flipping the sign, it's because I'm doing something to both sides of the equation. But when you're dividing by that 6, we're not like dividing by 6 over here with the 0. We're still just figuring out what are the factors for that left-hand side. Maybe that helps. Yeah.
Yes, thank you.
Yeah. So maybe one way to think about it is actually to just ignore that that's even there, right? Because our first step was really that we needed to get a 0 somewhere and get it factored. But all of this stuff was just to get us factored. Okay, fast forward back to my greater than or equal to 0. Now that I'm looking at this, I need a number line. I guess I'll put it down here. And the numbers that I'm going to put on my number line are whatever X values make one of these pieces equal to 0. So 3x minus 2, I'm going to do it in my head. It's totally fine if you write it on your paper, but that's going to be positive 2/3 is what would make that equal to 0. And negative 1/2, if we plugged that in for X, is what would make this equal to 0. Now, I know we have fractions up here that make some people uncomfortable. It's okay to live in that discomfort for a minute. Here's the good news. You don't have to plug in fractions to this equation. And if you look at 2/3 and you're like, yeah, I don't know, is it less than 1? Is it more than 1? Who cares? If I need a number over here bigger than 2/3, just go big. X equals 100. Even if you look at this fraction, and you're like, I don't know what it is, you can give me a number that's bigger than it. Same deal on the other side. Well, hopefully negative 1/2 feels more comfortable. But if I'm looking at negative 1/2 and I need a test number to plug in over here, I'm like, how about negative 10? And then the one to not forget about, if something's negative and something's positive, 0's in the middle. Now I don't have to think too hard about the fractions and what their values are. We just need to plug in these test points and figure out in each piece, are we positive or negative? Do you want me to give you a second to do them on your own, or should I do them? I'll give you a couple minutes. You don't have to use my test numbers. If you're still plugging in numbers, that's totally fine. I wanted to just show you a couple of sort of shortcuts for dealing with this. And I'm going to start with the 0. I think I said before, but it doesn't matter because this left-hand side, this is an equivalent form to the factored version. It doesn't matter which one you plug into. For x equals 0, I think it's way easier to plug into the not factored form. So for x equals 0, that one I can do in my head if I go up to this version. I've got 0 minus some more 0 minus a 2. So for sure, when we plug in x equals 0, we're going to be negative. For the other numbers, we don't actually care what the value is. The only thing we're trying to figure out here is where it's greater than or equal to 0. So we just need to know if the thing works out to be a positive number or a negative number. So when I plug in x equals 100, I'm going to choose, personally, I'm going to choose the factored form. And if I plug in 100, I'm going to say 3 times 100, I can do that. 300 minus 2. When I plug in the 100, I'm going to have 200 plus 1. I don't need to waste time on this multiplication. I don't even need to write down that that's 298. The only thing I care about is this, that's for sure positive, and that's positive. And a positive times a positive gives me a positive number. When I plug in -10, same deal. I just need to know whether it's positive or negative. So when I put in -10, that's -30 minus 2 and -20 plus 1. Don't multiply -32 times -19. I don't care what the number is. That's a negative times a negative. So my final result is positive. This time when we write our final answer, a couple things. First of all, because of the or equal to, I know that I would have filled in circles. And because this says all of this needs to be greater than or equal to 0, I want the positive parts. So I want the part out here and the part out here. And the way that we would write that in interval notation is we'd have these two pieces and we join them together with a union or a U. So that piece over there on the left would look like -infinity to -1/2, square bracket because of the or equal to. And then I'm going to join it together with a union of the piece from 2/3 to positive infinity. I know there were some questions yesterday. Yes, it matters what order we write this in. We need to be moving from left to right on the number line when we write our intervals. Questions about any of that before we get another example rolling? Watching the chat. I think we're good. Yeah, so there's a really excellent question in the chat. And it's one of the things that can be kind of confusing about these inequalities. What we care about in the final answer is that this entire thing is greater than or equal to 0. Not that the individual x values are greater than or equal to 0, but what numbers, when we plug them in here, give us a final result that's greater than or equal to 0, or whether we look at that version or the factored version. So we know, because we tried it, when we plug in -10, even though we're plugging in a negative number, when we plug it in, the overall piece, whether we write it in its not factored form or its factored form, worked out to be a negative number times a negative number. So the overall answer is positive. So you can keep trying any number you want out here, but they're all going to work out to have positive values, because when we plug them in, we'll have a negative number times a negative number. Let's do another example. Oh, sure. So we read the U. There's a question about the U. We read the U as union. And it just means that we kind of stick it in there as a placeholder to say X could be over here or over here. Right? So if we think about on our number line, we're saying X could be over here or over here. I kind of think about it as we push a union in anytime we need to like split some things apart. I don't know. I know that feels backwards from union, so. Okay. Moving on to another one. Yes, the union is also showing we're not including the numbers in here. Yeah. If you want to get really fancy with the notation, you don't have to, but if you want to get really fancy with the notation, like the full notation for your solution would say X is an element of the set of numbers between negative infinity, I don't even remember what they were, and negative 1/2 union 2/3 to positive infinity. And I would read this as X is an element of the set of numbers between negative infinity or and negative 1/2 inclusive, or the numbers from 2/3 inclusive to positive infinity. No one's writing that? Oh, totally. Totally looks like a 2. Anyway, this notation, for those of you headed to the 21 series, you might have to use that notation sometimes. For the rest of us, mere mortals, not usually. Okay, let's get another one going. X squared and minus 6x plus 9, and we're going to go greater than or equal to 0 on this. I'm going to get this factored for us real quick. This one happens to factor as x minus 3 times x minus 3. Or if you want, we could write that as x minus 3 whole thing squared. We can totally get a number line going on this one. The only value that would be on my number line would be 3. And then I'm thinking about some test points. So on the left-hand side of 3, I'm going to pick my favorite easy point, x equals 0. And on the right-hand side of 3, I don't know why, I kind of like 10. When I plug in 0, and again, I usually tend to plug in 0 to the not factored form, because when you plug in 0, that goes away and that goes away. So when I plug in x equals 0, I'm just going to get 9, which is positive. And when I plug in 10, I'd have 10 minus 3 whole thing squared. That's 7 squared. It's definitely positive. Because that's an or equal to, I'd have a filled in circle on the 3. And because I want the positive part, that means I would take all of that and also all of that. when we write this in interval notation, it's a little bit weird, but it turns out that every single value we have makes this greater than 0. So when I put it into interval notation, that would look like negative infinity to positive infinity. And since I mentioned the fancy notation, we could also write that to say X is an element of the real numbers. That's how we read this fancy R. And we say real numbers to differentiate from imaginary numbers, like where we would be allowed to take the square root of a negative. I do not expect you, you are welcome to use this notation. I'm not expecting you to use the notation, but it does show up sometimes. Doesn't matter even slightly where you plug the numbers in. Personally, I plug the numbers in to whichever version is going to be easier to do the arithmetic. So for me, plugging the 10 in up here, then I'm dealing with 100 minus 60 plus 9. Okay, it's not so terrible. But for me, if I'm doing the arithmetic, I would rather plug the 10 in here and have 10 minus 3, 7 squared. Like I'd rather do that math. But it doesn't matter which version you plug them into. So each time I just pick whichever place looks easier to plug it in. If I was plugging in a 1, I'd probably choose this version, right? It's just wherever the math is easier. It's 10:08. I want to take a little break. And when we come back, we will do some slightly trickier ones, but same idea holds. So clock says 10:09, come back at 10:14. So I will get started back up again. I am now on example 4 from set O, if you all are playing along. So the next inequality that we have on here, I'm just going to give us in factored form because it's not quadratic, it's cubic. And in general, we don't have great methods for factoring cubics, and it's not expected of us very often. The one exception, we should be able to factor a cubic when it's in the form a cubed plus or minus b cubed. That's the one that we are expected to know. For all other cubics, most of the time, we're not expected to do that factoring. So let's assume that we've already been given this thing factored. Well, I have 3 pieces and they're being multiplied together. And the final result needs to be less than 0, meaning we're looking for the negatives. So I'm looking for the negatives. And I already know that because it doesn't have an or equal to, I'm going to have open circles on my number line and be using parentheses when we put our final answer in. So those are kind of 2 things that we can pull out right from the start. Now, terrible options we're not doing. The thing that I would have done if I were presented with this before I knew about the number line thing, I'd be thinking about, gosh, I'm multiplying 3 things together and I'm getting a negative. So that could be like a positive, and a negative, or 3 negatives. Or I could have that negative here and a positive, or a positive and then a negative and a positive. And I'd be like working out all these different scenarios of what's happening here. The cool thing is, if we just stick with that number line, it's going to take care of all of that for us. I'm going to take each piece and I'm going to think about what makes it equal to 0 and put those numbers on my number line. In this case, I'm going to have -3, +2, +4. And now I only have to think about what are some test numbers that we can plug in each part. So if I'm thinking about test numbers here, I can put in, I don't know, how about -5 between -3 and 2. If I've got a negative and a positive, personally, I'm always choosing 0. Between 2 and 4, how about a 3, and bigger than 4, how about a 5? So these could be my test numbers. As you get more practice with this, or if you're good at arithmetic, maybe you can think about plugging those in your head. Sometimes folks find it useful to kind of make a chart just to keep track of things. So if I were making like one option just to keep track of what we're plugging in, would be to think about making a chart that had our different factors. So x plus 3, x minus 2, x minus 4, and then like the total or the overall. And then think about plugging in each of our test points. So I'd have the -5, the 0, the 3, and the 5. You do not have to do this. It's a lot more writing, but especially at the beginning, if you're having trouble kind of keeping track of it all, sometimes this can be helpful. So if I were using a chart, first I got my number line, I'm getting my test points, and then I'm thinking about plugging the numbers in. So if I plug in -5 to x plus 3, -5 plus 3 would give me -2. And you can either put -2 in the chart, or since really we just care about the sign, I'm going to put a minus sign in the chart. If I plug in -5 to x minus 2, -5 minus 2, also negative. -5 minus 4, also negative. So the total or my overall would come from doing negative times a negative times a negative, and my overall would be negative. So I'd have a minus sign in here. When I think about putting the 0 in, 0 plus 3 is positive. 0 minus 2 is negative. 0 minus 4 is negative. And my overall would be a positive times a negative times a negative. So my overall here would be positive. If I plug in 3, 3 plus 3 is positive. 3 minus 2, positive. 3 minus 4, negative. Positive times a negative, give me a negative overall. When I plug in 5, 5 plus 3, that's positive. 5 minus 2, also positive. 5 minus 4, also positive. Positive times positive times positive, also positive. And then I just copy these signs over to my chart. I get a negative and a positive. Next up, because I don't have the or equal to, everything on my chart would have open circles. And I would say, I'm looking for the negatives. So I need the part over here and the part in here. When I write my final answer in interval notation, starting from left to right, that would look like negative infinity to negative 3, union, to show that I'm taking out this piece right here, 2 to 4. This is really kind of a minor and subtle thing, but I find it especially helpful if you're ever trying to look back and either find a mistake or kind of remember what you did on the problem. It's important to somehow differentiate between the values that are on your number line because they came from the problem and the semi-random numbers that you chose as your test points. So for me, if I have 2 colors, I like to put my test points in a different color. Or at the very least, even if I'm not working with 2 colors, I make sure that my test points are somewhere like below and kind of offset from the actual number line so that I don't get mixed up later of like, oh wait, if you put the 3 up here by the number line, then it can start to feel like 3 was something that should be in your final answer, but it's not. It was our kind of arbitrary choice of a test point. How are we feeling? You ready for another example? Cool. Okay. So far we've been doing things that factor with multiplication. We can use this same trick even if we've got rational expressions or we have some kind of division-y thing going on. So if I have x minus 4 over x plus 1, and this is less than or equal to 0, same kind of deal. I've got things that are being divided. I need the answer to be negative. So I either need a positive and a negative or a negative and a positive in order to get that division to work out to be overall negative. And we can do it the same way that we did once we had things factored before, which is anything that makes a part of this equal to 0 is going on my number line. My number line would have a -1 and a +4. there's just one subtlety that we have to keep in mind anytime we've got a rational expression, and that's thinking about what are the restrictions on the variable. Well, when I look at this, if we actually plugged in x equals -1, that's a restriction on the variable because it would make us divide by 0. So before I go any further, I'm going to think about this number line. This says or equal to. So naturally, both of these would be filled in circles, but I can actually only fill in the +4 because -1 is a restriction on the variable. So no matter what else happens, I know that I can't include the -1, but I can include the +4. Now I'm ready for test points. So my test points here, between -1 and 4, I'm going to choose 0. Something bigger than 4, how about 5? Something less than -1, how about -2? There was a question in the chat about when do you use the chart that I had out on the other one. You can use it on every problem, or you can use it on no problems at all. It's entirely up to you. My tipping point is usually if I have 3 or more numbers on the number line. I just sometimes feel like it's easier to go for a chart to keep track of things. In this case, I'm just going to plug them in and plug them in off to the side. So if I plug in x equals -2, I've got -2 minus 2 on top and -2 plus 1 on the bottom. So I've got a negative number divided by another negative number, and overall, it's going to be positive. When I plug in 0, I've got 0 minus 4 over 0 plus 1. That's a negative over a positive. So overall, I've got a negative. When I plug in 5 minus 4 over 5 plus 1, that's a positive over a positive. And overall, I end up with a positive. Then I check, and this thing says I was looking for the entire final total to be less than or equal to 0. So I want this negative part in the middle. And it's going to look like parentheses -1 to 4 with a square bracket. Yes, that should say -2 minus 4.
Why is one circle filled in and the other isn't?
So the one that is filled in, so let me start with the fact that it says or equal to would sort of tell us that we should fill in both circles, right? The or equal to part would say we should fill in both circles. We should be using square brackets. But then we have to turn in our other piece of logic, which is we have division going on and I can't divide by 0. Because I can't divide by 0, that means x equals -1 is restricted from being a possible value, right? So if I were solving this thing, if this had an equal to and some stuff over here, I'd have to keep in mind the restriction on the variable says I can't divide by 0. So even though we kind of want to fill this in because of the or equal to, it's going to be an open circle to indicate we can't actually plug in the -1, which is the same reason why the -1 needs to have parentheses, but the 4 gets a square bracket. So this tells me I can plug in the 4. And if we do plug in the 4, we'd have 0 divided by 5, which is equal to 0. It works. But when I try to plug in -1, I'd end up with -5 divided by 0. That's a problem. So I can't include the -1, so we give it parentheses instead. One more example, the worst one of all. We've saved the most complicated one for last. Well, that just looks messy. I have an inequality, but if this were an equal sign, right? If it were an equal sign, I would be telling you, hey, let's just multiply those fractions away. I do not have an equal sign. I have an inequality. We're going to have to go get ourselves some common denominators. And most importantly, we need to get ourselves a zero somewhere. So it doesn't actually matter a whole lot at this point which side we put things on. I'll go ahead and subtract this over to the left-hand side and make this say 3 divided by x minus 2 minus 2 divided by x minus 3 is greater than 0. Before we go any further, I already know x can't be 2 or 3. That's my restriction on the variable because that's either of those would make us divide by 0. But now I'm going to want to get a common denominator. And when I get that common denominator, that means this term has to be multiplied by x minus 3 over x minus 3. And this term has to be multiplied by x minus 2 over x minus 2. Now I have the common denominator of x minus 2 times x minus 3. And on top, we're going to carefully distribute things out. So I've got a 3x minus 9. And I've got a negative 2x. Negative 2 times negative 2 is going to give me a positive 4. And when I combine all of that together, 3x minus 2x is going to leave me with an x. Negative 9 plus 4 would give me a x minus 5 all over x minus 2, x minus 3. So now I've got 3 things for my number line. I need a 5, a 2, and a 3. Isn't that fun? It's up to you. But I know that we're going to have 4 test points to plug in now. I'm going to choose 0, 2.5, 4, and 6. Because I have 4 test points to plug in, personally, I might choose to switch to a chart, but it's really up to you. I'm going to go ahead and chart it up real quick. So if I were making the chart, I'd have all of my factors. So x minus 5, x minus 2, x minus 3, and then my total. And I'd have my test points of 0, 2.5, 4, and 6. And then I start plugging numbers in. When I plug in the 0, I've got 0 minus 5, that's negative. 0 minus 2, also negative. 0 minus 3, also negative. Now, when we think about the total, we've got x minus 5 divided by x minus 2 times x minus 3. When you multiply those together, you'll get a positive, and a negative over a positive gives us a negative overall. When I plug in 2.5, or if you prefer fractions, you can use fractions. You can call that 5 halves. But if I plug in 2.5, 2.5 minus 5, negative. 2.5 minus 2, positive. 2.5 minus 3, negative. I've got a positive times a negative, which should give me a negative in my denominator and a negative in my numerator. So overall, that's going to be a plus. If I stick in a 4, 4 minus 5 is negative. 4 minus 2, positive. 4 minus 3, positive. Did I do that right? Yeah. Positive times a positive. And then a negative divided by that positive makes that negative. I plug in a 6, 6 minus 5, positive. 6 minus 2, positive. 6 minus 3, positive. Positive overall. And then I come back to here and say, or here, oops, I lost my greater than 0. Come back to here and say, I want it to be greater than 0. So I'm looking for the positives. Because there's no or equal to, they're all automatically going to have open circles. And I wanted the positives and some more positives. So writing in my final answer would look like 2 to 3, union 5 to positive infinity. How are we doing on 10? Okay. Yeah. So my total row is thinking about the overall composition of the thing. If you have an odd number of negatives, the whole thing's negative. How about that? Because if we have this total row is coming from doing the x minus 2 times x minus 3 term, and that's what's in the denominator, and then my x minus 5 is in the numerator. So that total row I've got like here, that'd be a negative times a negative, which would give me a positive on the bottom. But then a negative over a positive would turn it back into a negative. Kind of the shortcut, the shorthand way of thinking about that is whether we're doing multiplication or division, if you have an odd number of negatives, right, all the like pairs of negatives are going to turn into positives. So if you have an odd one out, your overall would be negative. If you have an even number of negatives in there, then they'll all pair up to give you positive values. And if you don't like the chart because all of that feels messy to you, you don't have to use it. You could just take each of your test points and plug it into the overall fraction if that feels better. So like if, let's say I was plugging in x equals 4 to my chart, I'd have 4 minus 5, or sorry, not to my chart, but just directly to the equation. I'd have 4 minus 5 over 4 minus 2 times 4 minus 3. And that's a negative over a positive times a positive. Overall, that'll be negative. chart or just plug it in, doesn't matter to me. We've got 5 minutes left. I'm going to do one more example. Erasing stuff. I just want to get like one more example worth of practice. So I'm not going to worry. I'm just going to give us a thing that's already factored. And heck, I'm going to give it to you factored, and I'm going to give you the number line. You just have to practice writing the final answer. Deal? So, we're going to have, how about, I'm going to make it real messy. X minus 1, X plus 2, X minus 3, X minus 4. I don't know, let's cube this and square that. It looks dreadful, does it not? Okay. I'm going to give you the number line though. Oh, and we want this to be, let's say, less than or equal to 0. And on my number line, I would have a -2, a 1, a 3, and a 4. And this would look like, just making sure I got all my numbers in the right places. So I would have that was kind of boring. Hold that thought. Okay. Do not go plugging in test points. I did the work for you. Assume that my number line is correct. I just want you to practice the notation-y part of figuring out what is this telling you in terms of your final answer.
Isn't that the same sign you had in the first place?
Oh, thank you. I was trying to make this greater than or equal to 0. I was trying to give you the messier one. Thank you for pointing that out. Okay. Let's get our final answer in here. And a few of you have put some answers in the chat. Let's see how we're doing. So for starters, I'm going to say I have a restriction. X can't be 3 and it can't be 4. So those for sure are going to be open circles for me. Next thing I'm going to look at, this said or equal to. It's totally fine to have a 0 on the top, which means 1 and -2 would both be filled in circles. Now, I care about the greater than parts. We want all of the positives. Now we can write our final answer. There's something really subtle about what we're going to do over here. And over here, although it is tempting to think about going from -infinity to -2 brackets, and then bracket -2 to 1. This union implies that you've had to like wedge a little hole out somewhere. But we didn't wedge anything out. We're using the -2. So this is actually incorrect notation. We're continuous all the way from -infinity over to +1. Then we are going to take a little piece out here and go from 3 to 4. And even though there's only a single point that we took out, we did take a little point out. And now we're going from 4 to +infinity. So there are 2 unions, not 3. I will never give you something this messy. No, that's not true. You might have something this messy on the homework. I would never give you something this messy on a quiz or a midterm. Just wanted to practice with it a little bit. And
I had a quick question. What did you mean by like take a little wedge out? Is when you went from 3 to 4, that's where I was off hard.
so I can't include 4. So I need to write a union anytime I've taken something out, right? Like anytime there's something in the number line that I'm not including in that span, I have to put the union in there. So the first union is happening because we're leaving out all of the numbers between -1 and 3, because those would have made my overall thing negative. And the second union is happening because of that restriction on the variable and having to remove 4 from the possible values. Okay, I'm gonna call that good. I'm gonna stop recording.